So first of all, I want to thank everybody for attending our Lunch and Learn training, our virtual Lunch and Learn. If you're like me, you're minus a lunch right now, but that's okay. You know, I do appreciate you coming out. You know, a lot of this really, the impetus or the reason we started this was due to the COVID-19, and you know, we heard from a lot of customers and a lot of end users that we love you guys, but we really would like to, because of the shelter in place, not see you for a while. And we wanted to respect that from everybody. And we started thinking about ways we can still keep water conservation moving forward, still connect with people, especially because everybody's been sheltered in place for a while now. We started to think these training programs might be good and helpful. So we put the email request out earlier this week, and we were really happy with the amount of people who are attending. So thank you. We really appreciate that and appreciate your participation. Because we're going to have quite a few people on the line today, it might be difficult to ask a question through the audio. So please feel free to use the chat function. I'll be monitoring the chat and passing those questions on to Andy Belingheri today. And I do want to take a minute now to introduce our speaker today, Andy Belingheri. He's a national sales manager at In-line Irrigation. I've worked with Andy for over 5 years now at Jane, and we worked together before this at Valley Crest companies back when before Valley Crest became Brightview. You know, Andy got his degree in horticulture at BYU, came out of BYU and started as an account manager at Valley Crest right out of the gate. So the thing I really do appreciate about Andy is that he's got a lot of hands-on experience managing people, understanding irrigation, and a real passion for horticulture as well. I saw him do this presentation a couple months ago at Utah Green in Salt Lake. And I said, Andy, this is a great presentation. I think everybody's going to really enjoy. So, and I know you guys will. So with that, I'm going to say, welcome, Andy. Thanks for doing this. And I'm going to turn it over to you.
Well, thank you, Richard. I appreciate that. Very, very kind introduction. You know, as you mentioned, this presentation we delivered at UNLA show in Salt Lake, and we pared it down a little bit. We got a lot of ground to cover in the next 30 minutes or so. But if you do have questions, please shoot those via the chat function over to Richard, and we will get those answered. So our topic today: point source versus inline drip. And we'll go through some of the components, the product themselves, design, installation, and overall operation of the system. Ultimately, you should walk away from this presentation knowing how to choose which system is best for you. And you know, I thought we'd start today with just a definition of what is point source and what is inline. As you can see this picture on the left, we see some 1/4-inch tubing with a button emitter at the end of that, providing water from a source to a specific point. On the right, you see a 1/2-inch tubing with an emitter built into it. That is Emitterline. Pretty basic definition. For our point source on the left, our typical flows you'll see, and this may vary, but 9 times out of 10 in the landscape, what you see is a 0.5, 1, 2, or 3 gallons per hour. And probably 1 or 2 are going to be the most common with point source. In our inline or Emitterline style of irrigation, we see a wider variety of flows, anywhere from a point, even 1.7 I've seen, but a 0.29 gallon per hour up to 1 gallon per hour. Now, from my experience, not just here in Las Vegas, but throughout the Western United States, 0.5 gallons per hour and 1 gallon per hour are going to be the most common. Now, source and inline irrigation do share some commonalities, and I want to touch on a couple of these commonalities that are non-negotiable, that become absolutely imperative in our irrigation systems. The first is going to be pressure compensation and pressure regulation. Pressure compensation is nothing more than making sure the flow stays the same regardless of pressure differential. Pressure regulation, of course, is just what it said. It regulates the pressure, keeps pressure in the operating norm for a drip system to use. Regardless of point source or inline, we want to make sure we are always using pressure compensating emitters and always using a pressure regulating device. So that's one thing that both of these systems will have in common. Every drip system, we want to make sure we employ those two things. And the other thing we want to make sure we're employing in any drip system, whether it is point source or inline, is a good filter. Filtration keeps debris out of the lines that would otherwise plug up the emission devices, whether it be inline or point source. As you can see with this picture on the left, we got a couple of different styles of filters to choose from. We have that upper picture, that's a disc filter. You would use a disc filter if you had organic growth or algae, moss, for example. If you're trying to filter that out of your water, you would use a disc filter. The lower picture, that big silver screen you see right there, that is of course, a screen filter, and you would use that if you were filtering out sand or shell or any type of debris. Again, regardless of the drip system, a filter is an absolute necessity. One other commonality between the two systems is the necessity to flush, and I'll just touch on this briefly. Whether you're flushing your system manually by either undoing your cap at the end of the line or undoing the figure 8, or if you're employing an automatic flush valve that flushes the system automatically, we want to make sure we are flushing the lines. What will happen is sometimes, especially in hard water environments, the mineral deposits can build up on the inside and potentially plug the emitters. Or if there was a break in the line and debris got inside there, we can use these devices to keep the system clean. And that just becomes a good system maintenance there. So those are three of the commonalities I wanted to touch on between the two systems. Now, let's get into some of the specifics, differences between the two. Let's start with point source. This upper right-hand picture, you got a couple examples of point source emitters. The one on the left, the upper right-hand picture, you see those two emitters. The left, the gray and green one, that is just a typical button emitter. That would be emitter as well, but it is take apart. You could take it apart and clean it. The picture just below that is an example of a point source manifold. You can see this particular picture has 4 ports. These manifolds exist in 6 and 8 port units as well. Those are probably going to be the most common out there. And you can see a 1/4 inch line runs off that manifold out to the plant. The picture in the lower left-hand corner is an adjustable emitter. Again, consider point source and something you'll occasionally see out there. For a commercial landscape, I would not recommend something like that for the sole point that it is not a pressure compensating emitter. And in my experience, those adjustable emitters have a tendency of loosening up. The cap falls off, and the next thing you know, your landscape looks like a Bellagio fountains with shooters squirting up all over throughout the landscape. But as you can see here, these are some examples of point source emitters. Now, as we get into Emitterline, right, kind of the inside workings of Emitterline. Emitterline in the landscape typically is going to come in either a 1/4 inch variety or a 1/2 inch variety. This picture on the upper right you see is 1/2 inch, and you can see the outline of an emitter that is built into the tubing. The tubing is extruded with an emitter built onto the inside. And from that emitter, of course, water comes out, and you can see in the picture beneath that what that emitter looks like. There's, believe it or not, a lot of technology that goes into the development, excuse me, and construction of those emitters. And then you've all seen this before, the picture on the left, a roll of Emitterline with that emitter built into it. There is a spacing difference in this Emitterline. Typical spacing for the 1/4 inch is going to be 6 inches and 12 inches, For the half-inch emitter line, 12 inches, 18, and 24 inches will be most common in the landscape. So those are the the basics of the two different systems, right? Point source and emitter line. When we get into which one to choose when we're designing, there's a few things we want to take into consideration. The first is if you look in this picture, this layout of the landscape, the upper left-hand part of this picture, we see trees. Each of these trees are the same. They're going to have a similar water need. They would all be on one valve, for example. If we look down here in the lower right-hand part of the picture, you see some turf, for example. That's going to have a similar water need and would be on a separate zone. Or we look at a slope. You know, slope's going to have different water requirements, especially in frequency and duration, than everything else would. So that would be in a different zone. So this gets into some of these principles of hydrozoning. You know, different water requirements between turf and trees, or annual color beds and native plant material. Of course, different types of soil have different water needs. Exposure affects this, as does our slope. That's our first consideration, right? As we're beginning to design and choose between which is correct, point source or emitter line. There's a few other considerations we want to take into account as well. These are some of the design elements. I get these questions all the time, and these are sometimes some of the most common questions. How big can I make a zone? Which size valve do I use? What size filter? What size regulator? How many point source emitters can I put on a valve? How much emitter line can I put on a valve? How long can I run those laterals? And the answer to every single one of these questions is flow. And there are some differences here between point source and emitter line. And that has to do, first difference here is in the size of the tubing itself. With point source irrigation, most of the time you're dealing with half-inch tubing. Although I will say, I know some of the good contractors in Las Vegas and the Arizona area are doing more 3/4 inch tubing in their point source applications. But even for the guys that are using half-inch, believe it or not, there are 4 different sizes of half-inch tubing. There's 16 millimeter, there's 17 millimeter, got 18 millimeter, and then we got this 700, 600. And it's important to know which size you're using, because the hydraulics, the water flow through those tubing will change. And that's going to have an impact on how many emitters you can use in your zone. Now with the emitter line, it gets a lot easier. 99 times out of 100, it's going to be half-inch in landscape. In fact, I would say 99.9 times, it's always going to be half-inch. And the vast majority of those scenarios are going to be 17 millimeter tubing. If you look at this picture here on the right, that brown roll of tubing, I think anyone who's ever used emitter line before, that roll of tubing they used looks similar to that. It was brown, it was 17 millimeter, and then it had emitters built in. And again, it's important to understand the size of the tubing we have, because that gets into our ability to design with these different elements. So okay, so going back to that question a couple slides ago, how many emitters can I have on a zone, or how much emitter line can I have on a zone? Remember, the answer was flow. So with point source, let's start with point source. How many plants do I have? And then how many emitters per plant? And then lastly, what's the flow rate of the emitters? And we use that to calculate the total flow. If I know how many plants, how many emitters per plant, and the flow rate of each emitter, I can calculate my total flow. The emitter line's a little bit different. With the emitter line, we want to calculate, we need to know how many total feet of emitter line we have. And then we want to know the spacing between the emitters. Is it 12 inches? Is it 18 inches? Is it 24 inches? Once we know that, and we'll look at the flow rate. And then we know the flow per foot. And once we know the total feet, we can calculate our total flow. And then it's just as simple as working backwards. I take the total flow of my landscape and divide that by the total flow capability of my valve filter regulator combo. So if the typical valve filter regulator combo, depending on the size, whether it's 3/4 inch or 1 inch, that flow could be between 9 to 18 gallons per minute. I could divide that into the total flow of my landscape and come up with the size of my zones. I will make one recommendation here, and that is this: whatever your total flow is, cut that number in half. So for example, if my flow of my landscape was 100 gallons per minute, and the capability of my valve filter regulator was 18 gallons per minute, I would cut that number in half. So for example, instead of using 18, I would probably use 9 or 10. I'll use 10 because it's an easy number. And if I took that 10, divided the total flow of the landscape by 10, that would give me 10 zones. And the reason I do that is it allows me to expand the drip system down the road. As everybody knows, plants grow. As root systems grow, we need to expand the irrigation system. And by doing that, cutting that in half, it allows us to expand the irrigation system in the future. So I would like to make that point. The other question that came up then was, how long can I run a single lateral? We'll start with point source. Good rule of thumb, 200 feet. This comes right out of our contractor design guide. 200 feet is a good rule of thumb for a blank lateral. Of course, you could do more, but remember, we want to be conservative in case we need to expand the irrigation system down the road. Now you ask yourself, how many emitters can I put on a valve? Well, again, we got to look at the valve size and the flow, and then the flow of the individual emitter. So for example, if I had a 1 inch valve with a flow of 5 gallons per minute, and I had 1 gallon per emitter, 1 gallon per hour for each emitter, I could have a total of 300 emitters. Now, maybe some of you are snapping out your phones right now, taking pictures of this. We make this very easy. These charts, there's no need to memorize them. They are the back of catalogs. Every manufacturer has in their catalog a chart similar to what you see here on your screen now that will tell you what is your maximum run length of a lateral. For Emitterline, for example, you can see a chart like this. If I have a 12-inch space Emitterline and the tubing size is 700 by 600, my flow is 1 gallon per hour, my pressure is 25 psi, I can run a lateral 169 feet. So these resources are available in catalogs, on our website as well. Every manufacturer will publish information like this for their particular product, whether it's Emitterline or blank tubing itself, and then you'll use these charts to aid in your design process. A couple other things to keep in mind. I know we mentioned length of lateral, but as you're designing, this is true for both point source and Emitterline, keep in mind the slope or grade changes. You may need to make sure you're using a check valve, for example, if you're on a steep slope. You're always going to want to know your point of connection size and what the flow is there. And then, of course, we already talked about the valve size. And again, once we figure out the flow of the landscape, we know the flow of the valve, we work backwards, and whatever that number is, cut it in half to allow room for expansion down the road. Okay, now getting into to more of the nitty gritty, I guess, with design specific with our point source setup. Again, remember, point source could be 1/2 inch or 3/4 inch supply tubing. If you look at this picture on the right, you see some trees and shrubs spread out, and you see this supply tubing running around. The water flows through that. Now, to get the water from the tubing over to the plant, we use a 1/4 inch spaghetti tubing connected with 1/4 inch barb fittings, and then a point source emitter attached to that to allow the water to get to the shrubs. When would you use this? Well, this is going to be ideal for spread out landscapes, xeric landscapes, native landscapes. If it's kind of a sporadic plant spacing, a plant here, a plant there, you're going to want to choose point source as your irrigation method. And again, this can be installed above ground or below ground. I think from an aesthetic standpoint, at least covering it with mulch is going to be ideal. It just makes for a cleaner install, but it can be installed below ground as well, and it is done so very successfully. And here we just have a simple picture. If this were installed below ground, what that would look like, you can see A right there, that's pointing to our tubing. B, we've got an emitter plugged in to the tubing. D is our 1/4 inch tubing that comes up off that, comes up above ground. It's got a little bug cap on the end of that, and it delivers water to that plant. That is a basic point source drip irrigation design. Next, as we transition over to our Emitterline, when would you choose Emitterline? Well, if your plant spacing is tight, if it's very dense, if it is an environment where you want a high distribution uniformity, you're going to want to choose Emitterline. And you could do it in a grid, as you see pictured here. And it doesn't matter, I could drop a plant anywhere within that grid. It's going to get water, it's going to live, and I could have a nice dense planting area. And you could do it in a grid like this, or you could do in tree rings. In the next slide here, you'll see some examples of what those tree rings or shrub rings would look like. Again, this would be dense spacing, formal landscape design, annual color beds. That's going to be the ideal scenario for Emitterline. Or if you're looking, as you see here, the rings. What's the beauty of these rings are you could do a single ring for these shrubs, or if you had a large tree, you could expand this line upon line upon line and go out 20 or 30 feet to meet the irrigation needs of a tree. So these tree rings become very valuable. And last but not least, I will mention Emitterline is the way to irrigate turf if you're using drip irrigation. And you can see in this picture here, you've got a PVC header, a PVC footer, Emitterline in between, and it will be ready to go. Now the question arises then, how do I choose the spacing for Emitterline? Do I go 12-inch spacing on my emitters? Do I go 18-inch spacing on my emitters? Or what about the space between the laterals here? Is that 12 inches? Is it 18 inches? Is it 24 inches? The question then becomes, how far should these emitters be spaced? The answer is, well, it's the soil, right? Depending on the type of soil you have. Now, there's a lot more than just, fast, moderate, and slow. There's a few in between, but we have some general rates here that will help you out. If you have a sandy soil, a fast draining soil, your emitter spacing along your emitter line should be 12 inches. A lateral spacing, 12 inches as well. If it's a moderate soil, 18 inches on your emitter spacing, 16 to 22 will be about right on the laterals. And if it's a heavy clay soil, you could go 24 inches on the emitters and 18 to 24 on the lateral spacing. And that's how you'd space those out. Point source, emitter spacing. I'll show you this slide here. I see this mistake. It's made commonly with trees especially. A guy will put one emitter next to a tree. And that tree needs 63 gallons of water, let's say, and they'll put that one emitter there and say it's a 1 gallon per hour emitter. And they'll let that emitter run for 63 hours because that's how much water the tree needs. As you can see in this slide, the trees aren't happy with that, right? Or shrubs. If the water is in one spot and not spread across the root zone, they struggle. They struggle, especially when it gets hot outside. And so what you want to do then is spread these emission devices across the root zone of the tree. And we get into the question then, okay, so could I do this with point source, or do I do this with the Emitterline, right? How do I choose which one am I going to do? As you can see here in this example, it's just point source. And on this next slide here, I'll show a couple examples here. Let me just get the information up on the screen. If I had a shrub with a 2-foot canopy, if I go back to my high school math, I know pi r squared, that would get me an area of about 3 feet, a root zone of about 3 square feet that needs to be irrigated. Depending on the soil type, 1 to 3 emitters would take care of that. And you can see that illustrated in this picture right here. You see the tree, and you see the wetting pattern of the emitters that cover the root zone. But if I increase that canopy from 2 to 20, I greatly increase the number of emitters I need. Our square footage goes from 3 square feet to 300 square feet. Which means 300, we have 100 times more area. We need 100 times more emitter. Now, if you've ever installed irrigation, you know that putting out 3 point source emitters, not a problem. If you had to put 100 around a tree, that becomes problematic. So in the question of do I use point source or do I use Emitterline, sometimes the answer is how many emitters do I need to put out there? If I'm putting out a couple, point source makes sense. If I have to put out many, I would use Emitterline. This is a kind of a goofy drawing, but you get the representation of how that would work, a tree ring. The next few pictures, I think, is as we here to wrap up, I just want to show some examples of these different styles of irrigation and use. You know, I mentioned earlier that if you had turf, the way to irrigate turf with drip irrigation is using Emitterline. Drip is 2 times more efficient than spray. So if you had a hard to irrigate area or area you didn't want overspray, you could use some subsurface drip irrigation, and this would be Emitterline. And you can see a couple representations here of what that would look like. Again, we talked earlier about if you're using Emitterline, it's great to use in high density planted areas, tightly planted areas. You can see here, these would be either color beds or shrub beds that you wanted to irrigate every square foot and jam a lot of plants in there. That's when Emitterline starts to make sense, right? Point source. If I had a native area, you see these pictures below here on the left, native area that maybe water usage isn't as much, you know, water at just a point will be plenty. I would stick with point source. If I had a sporadic layout, I apologize, a sporadic layout, as you see here in this picture in the lower right, a plant here, a plant there, I'm going to be using point source emitters. So for drought tolerant, sporadic, large plant spacing, isolated plant material, I'm sticking with point source. Emitterline, tree rings, or high density planted areas. Anywhere where a high distribution uniformity is required, I'm going with Emitterline. And I will say one last thing here. I've prepared a checklist for you all at the end that we'll leave up here as you ask questions. But I will say one thing about the technology used in your drip irrigation your drip irrigation product. Stick with stuff that is of high quality. There's an old saying, you buy once, you cry once. Stick with high quality tubing that will last 10 to 20 years. Stick with fittings that don't blow apart. And with the Emitterline specifically, stick with something that has a physical root barrier. My friend's a par 3 landscape in Las Vegas. My friend Curtis I took this picture. This was from a job site, I believe it was Red Rock Resort. The roots had grown into the emitter itself. This was some subsurface irrigation for a planting bed. Roots got in, completely plugged up the hole of the emitter, and then you can see that picture on the left, big dreadlocks growing all the way down the tubing. If you choose an Emitterline with a physical root barrier, you can avoid costly root intrusion scenarios just like that. So I do want to throw that out there just as a word to the wise. You know, don't be fooled by low cost and low quality. And then summary, just to summarize here, as we go through our decision-making hierarchy on whether we choose point source or inline irrigation, make sure we cover the basics. We need to have pressure compensating emitters. We have to have pressure regulation, absolutely mandatory. You've got to have a filter. You cannot do drip irrigation without a filter, right? We need to know our flow rate of the emission device itself and the total system flow. And remember, let's design to half. Let's give ourselves room to expand that the irrigation system down the road. You may need a check valve if you're on a slope. We want to make sure we're flushing the drip irrigation system to keep it in tip-top shape. I recommend an automatic lateral flush valve. And then ultimately, as we're deciding between point source and Emitterline, if our landscape plant spacing is sporadic, if it's a loose design, if it's native, if there's small plants or isolated plant material, you can go with point source. If your landscape has got a tight density, tree rings are needed, you're irrigating turf, a very formal design, an annual color bed, anywhere a high distribution uniformity is desired, we go with Emitterline. And that's the end of the presentation. I'll leave the summary checklist up here in case anybody wants to take notes. I'd be more than happy to share this presentation with anybody as well. But I'd love to open this up to questions. Richard, I think I saw a couple pop up. Did you have those?
Yeah, thanks, Andy. A couple questions to start out with. Number one, great job. I wanted to say that definitely. And I want to ask you about the flush valves. I see it on the summary checklist. You mentioned the flush valves early on. When you're actually out in the field and you see jobs, would you say you see a lot of flush valves on jobs?
Not as many as I like to see. It's tough. Look, I spent close to 20 years as a landscape contractor. I understand the pressures of maintaining a commercial landscape. It's all about how green the grass is, how beautiful the flowers are, and are there any weeds or trash, right? Too often the things that are out of sight become out of mind. And unfortunately, a lot of contractors aren't taking the time to flush the drip zone, and that causes problem for them down the road. So, you should be flushing your drip zones, depending on the quality of the water, quarterly, maybe monthly, but that ends up not happening because guys are too concentrated on picking up trash, pulling weeds, mowing the grass. If you went to an automatic lateral flush valve or any type of automatic flush valve, you're saving labor. The system flushes itself, and there's no need to go through and manually do it. A few dollars on product saves you hundreds of dollars in labor down the road. Not to mention the potential failure that could happen from plug systems. So I would like to see more contractors using flush valves. I think that would make a big difference in the overall quality of their drip systems and also the manpower used to maintain the landscapes.
Yeah, so thanks, Andy. We got a couple follow-up questions to that one. So you go out to a job and you see some of these components are missing. How hard is it to build them into an already existing system?
So flush valves are not hard to build into an existing system. Every drip system is typically going to terminate somewhere. I've seen guys bend the tubing over, wrap it up with irrigation wire, and that's how they end it. You could cut that off, put a flush valve in right at the end, putting it in a little box like the. Let me go back here, if you guys don't mind. This is a great design Michael Derwenko that with J Irrigation did for us. You can see here. Doing that at the end of the line is very simple. It's very easy to do. Some of these other components, you can add an emitter line underneath an existing tree that's been irrigated by spray retroactively in a turf conversion. You can do it keeping the turf in place. We've seen our guys in Kern, California do that. So it is possible to come back and retrofit any irrigation system with either converting spray to drip or upgrading existing drip. It's definitely doable.
Yeah. Okay, great. Thanks, Andy. And so now we have a question that's about putting subsurface drip in lawns or in turf. And how deep should these lines be? And how would something like this work with Bermuda grass specifically?
It should work just fine with Bermuda. I like to, let me go back to this slide here. You bring up a good point with how deep the line should be. If we're doing our jobs as contractors, we are aerating turf, right? So we got to make sure these lines are buried deeper than the tines of the aerators we're using. 6 to 8 inches seems to be the norm. That seems to be about right. But you've got to keep into account your soil, the physical properties of your soil as well. Subsurface drip for turf, the biggest issue isn't so much how deep it is and whether it's getting hit by core aerators. It's, do you understand the physical properties of your soil? And are those physical properties consistent? So if I have sand on one part of my grass and clay on the other, it's going to be hard to, I'm either overwatering, flooding one area, or I'm underwatering the other. So having a consistent soil texture is going to be key. And then understanding that texture so I can get the spacing on emitters and spacing on laterals built into the system. And when that's done well, it is done very well. A friend of mine did it in his backyard, and his grass looks beautiful. And it's been going on 2 or 3 years. So when it's done right, it can be very, very effective. And use half the amount of water you would typically use with spray.
All right, great, thank you. Another question about flush valves, and what are the pros and cons of using a manual flush valve versus an auto flush valve? How do you feel about those two?
Well, the key is make sure you're flushing. You know, I go back to my days at Valley Crest and Par 3 and even other companies. I remember the single biggest direct expense was labor. Anything we could do to be more efficient with labor meant either more money earned at the end of the day, or the ability to be more competitive on the price we're delivering to our customer. And any technology I can implement in the field that reduces labor is going to make a big difference. So for example, manual flush valve versus automatic. If I'm having to send a guy out and manually flush the system, that's going to take time, versus an automatic flush valve that is doing it on its own. That gives my guy more time, maybe to do other irrigation inspections or whatever those other needs are out there. It becomes a labor savings. So my feeling is use technology so that each guy can do more with less.
Okay, great. Yeah, thank you. And yeah, labor these days, right? Very expensive and sometimes hard to find. So great point. I wanted to ask you too, how hard is it to, we saw some of those shrub zones and maybe some color beds in the late 80s, 90s, when they were pumping out homes like crazy. They were putting spray heads everywhere. And we have a lot of areas now that have sparse plantings, or maybe a lot of color, and they're still irrigating with sprays. Is it somewhat easy to convert a spray zone for color beds or shrubs into a point source or emitter line?
Yeah, it really is. I'm glad you brought up color beds. Let me go to this slide here, for example. If spray and color, I've never thought was a good idea, especially in these hot summer climates. The water droplets sit on the flower, the sun comes out, and the flowers always look, they always take a little bit of a beating. I've personally witnessed, if you're using Emitterline on a color bed, that water's applied at the soil surface, and the plants look so much more healthy and so much more robust. They don't take the beating of the water droplets. And especially in a color bed where you're ripping out that color and changing it, 1, 2, 3, 4 times a year, it's a great time in between a color rotation to convert from drip to spray. And some of the other shrub beds and turf beds, it's equally as easy. It's just a matter of understanding where the root zones are. So if I had a hedge of ligustrum, for example, I would want to understand how big the root zone is. I don't want to understand my soil properties, and then I'd run, 2, 4, maybe 5 lines, make sure I'm covering the root zone, and I just run that right along the hedge, cover with mulch, and it would be a simple conversion, as easy as getting the lines installed in the field. You could tee off an existing PVC lateral, and then going over to the valve zone and making sure it is being converted to drip. And that would require a filter and a pressure regulator.
Yeah, great. So now this one gets even a little bit more complicated, this next question, and that is, what about retrofitting a turf zone from spray to drip? You're going to end up saving a lot of water when you do that, but is it going to be so costly that it doesn't make sense? So what's your thought on that?
Yeah, so personally, I have never done that conversion myself, but I have seen guys do it. And I believe it was Kern Lawn Borders in California they had a machine, right, a trencher, that as they were trenching, they were able to install the drip irrigation tubing as they went. And kind of like a little slit, like a slit seater, but basically they could set the depth a little like a plow, vibrating plow, I think it was, and they could drop the emitter line right in. Depending on the price of your water, there's going to be a water savings depending on the price of your water. The return on investment could be short, it could be long. That just depends. But the guys are doing it, and I think they're doing it, somewhat successfully. But as far as specific numbers, I think it would really depend on the cost of your water. Cutting that water bill in half, right? What would that look like in terms of labor to make that conversion? It may take. It could be a short period of time. It could be a long period of time. It really depends on that cost of water.
Yeah. That's a great point on the water bill price, right? San Francisco, LA, San Diego, where average family of four is spending a couple $100 a month on water. Maybe that pencils out really quickly, where maybe someplace like Salt Lake or Phoenix, where it's closer to $50, it might not.
Yeah.
So Andy, this next question, I promise I didn't set it up. It really came from one of your viewers, and it's what is your take on the age-old question? And Andy and I had this discussion yesterday, but the age-old question of where to install the emitter, on the distribution line or at the end of the 1/4 inch line at the plant.
So I'm glad that question came up. And originally this presentation, I addressed both of those, and then after talking to Richard, we decided we would avoid the controversy altogether. But evidently, we're not avoiding this one. So I will tell you, the Irrigation Association, right or wrong, what they recommend is the emitter on the distribution tubing, the 1/4 inch spaghetti tubing coming off the emitter. Now, I will offer you my opinion. I know a lot of guys don't like that, especially in the desert environments where your irrigation system is buried underneath decorative rock. If and when that that emission device fails, you've got to dig through and potentially spoil your decomposed granite, for example, to get to an emission device that will probably, in a hard water environment, if you're using a cheap emission device, fail every 1 to 2 years. So what a lot of guys like to do is connect that 1/4 inch tubing directly to either the 1/2 inch or 3/4 inch distribution, bring it up right above the surface of the soil, and then put your emission device right on top. Now, there's a couple problems with that. Number one, again, let's go back to decomposed granite, for example, something I've personally experienced. If you're raking that decomposed granite, as you should, to keep it fresh, the tines of your rake will catch on that button emitter and could rip it right off, and that becomes a problem. Number two, sometimes rabbits or animals will come over and they'll gnaw on those emission devices. And the next thing you know, the irrigation system turns on, and you've got, again, the flagio. So it really is a trade-off. It's you're gonna have to make a decision which is best for you on your individual circumstance. It's drip irrigation. I can tell you, in 20 years that it's been in the Las Vegas and Phoenix market, we've learned a lot from it. Drip irrigation in other markets is still kind of slightly understood, and maybe some of the practices haven't quite kept up with the experience we've gained here in the desert. But anyways, those are a couple options. There's pros and cons of each way. I would say whatever you choose, just be aware of those pros and cons, and then do what's best for your scenario.
Well, Andy, I thought you walked that line, that very thin line, very well there. Thank you. Great answer. Someone else has a question about the paper-like drip tube that releases water upon the plant's hormones demand. I don't know if you have any experience with that or not, but if you do, or if you have some thoughts, I know we'd like some input on that.
Okay, so I've seen technology, and what they say is the plant roots communicate with this irrigation tubing, and these hormones communicate, and the plant, the tubing will either open up and allow more water or not. There's a couple inherent problems. I think if you're growing a crop in agriculture, if that theory is real, if this technology is real, I could see that potentially working. In landscape, you have an issue. You have root depths that can be as short as 3 to 4 inches or as deep as 24 inches. Where do you put that to begin with, right? Where do that's going to be part of the problem, is irrigating the root zone properly. And if the water's in the top 3 inches, right, that's where the roots are going to congregate. How do you get that water to go throughout the entire root zone to encourage deep rooting? I think trees also are advantageous. Most trees and shrubs and landscape plant material, not all, but most, will take as much water as you give them. And sometimes more is not always better. Sometimes you can have a drought-tolerant tree like a mesquite, for example, with very little water, and it still looks great. You give a lot of water, it might get bigger, but it doesn't necessarily look any better for the amount of water you're putting into it. So I think the inability to control the water it becomes problematic as well. So based on the limited knowledge I have, those would be my concerns. But I have seen the technology, and but with all that said, I don't fully understand that tech, and I may be misunderstanding the way they develop it. But it seems to me more of a row crop agriculture application if it indeed does what it says it does.
Yeah. Okay, well, great, Andy. I want to say thank you. That's the end of our questions this afternoon. Really interesting, thoughtful material. Really appreciate you presenting. Next Wednesday, we're going to have Jeff Toole from Jane Irrigation as well. He's going to be talking about satellite imaging and soil moisture sensors in the field to help you manage irrigation. And then on Friday, Michael Derwenko and Kevin Stewart will be talking about irrigation, using drip irrigation to irrigate hemp. So we're going to continue these for the next few weeks. We're going to try to stay on a 2 times a week schedule. Those of you who have asked for follow-up emails on additional information, we'll be getting those emails out to you. And then the other thing that seems to be on everybody's mind right now is kind of the state of the industry, who's working, who's not, who can work, what states are allowing landscaping as an essential service. I know Lawn and Landscape and Brian Horn are doing another survey out to contractors today. And I'll be on a podcast with Brian next week. And we'll get that information out to all of you where you can hear that podcast. We're going to be talking about the results and what people are seeing state by state. You know, we're really here partnering with you. We're all in this together. Appreciate your time and your interest in our subjects. And again, Andy, great job today. Thank you very much. And we will talk to you all soon, I hope. Thank you.
Thanks, everybody.